Today we'll be looking at integrating factor. Before I continue, do not forget to subscribe to this YouTube channel and click the notification bell to get notified for upcoming videos. Now, in solving the integrating factor, our equation is usually given like this, like what we have here already. Y prime plus P of xy equals Q of x. To solve something like this, or to solve an equation like this, we introduce what we call an integrating factor. An integrating factor. Okay, let our integrating factor be u, or let me say mu, sorry. Let's use mu, the Greek letter mu of x. We'll have it to be mu of x. We'll multiply everything we have on our left hand side, which is y prime plus p of xy. Now is equal to, we don't make use of what we have at the left hand side for now, so we have this all prime. Okay, open your brackets, and when you open your brackets, we have it to be mu of y prime plus mu of x py equals, here we have it to be mu y prime plus mu prime y. Now we have mu y prime at the left hand side and we have mu y prime at the right hand side, so those two can cancel out, or we can say collect like terms. We have our mu py, can also be written like this: mu y prime minus mu y prime plus mu prime y. Now our mu py equals, these two cancels out and we'll be left with mu prime y. Okay, let's bring things that look common terms, yes, like terms, let's bring them together. If we are to take mu, this mu to this other side, we have to divide both sides by mu. We divide both sides by mu, we'll be left with py equals mu prime over mu, and we have our y. The y here can cancel the y here, and then we'll be left with p equals mu prime mu. From here, this is also the same thing as you saying the mu dx. Let me put my mu here, mu dx. Okay, so we can take our dx here, where p is, it becomes p dx equals the mu over mu. From here now, we integrate both sides. We integrate both sides, we'll have p integral of p dx equals integral of the mu over mu. All right, when we take the integral of, this is the same thing as you saying 1 over mu d mu. Have it to be integral of p dx equals ln mu. We can also change the position. I just want to change the position, and here to be integral of p dx. Now to eliminate the ln we have here, we have to take exponents on both sides. Take exponents of both sides, and when you take exponents of both sides, it becomes exponential ln mu equals exponential integral of p dx, and exponential actually cancels out the ln we have there, so our mu is equals exponential integral of p dx. So this is our solution for integrating factor. Thank you for watching this video. Like I said earlier, do not forget to subscribe to the YouTube channel and to click the notification bell to get notified for upcoming videos.